Welcome to Excel 2013 Statistical Analysis video number 30. Hey, if you want to download this Excel workbook or the PDF files, click on the link below the video. Hey, in this video, we want to talk about Bayes Theorem. Now, Bayes Theorem is used when you have initial probabilities called prior probabilities, and these are often subjective probabilities. We are given or get new information, and we want to revise or update our prior probabilities by calculating what is called posterior probabilities. Now, our example will involve CPA exam. Our prior probabilities, you are going to estimate the probability that you can get a passing CPA score of 750 or more, and you're estimated it as 0.25. So that's subjective. And then you get some new information, and this is relative frequency. The new information, hey, a survey report that asked people who took the CPA, and they asked them two questions. What was their score, and did they take a preparation course? Now, the report reported these conditional probabilities. Probability that the person took a preparation course given that they got a passing score greater than or equal to 750 was 0.6. And the probability that they took a preparation course given that they got less than 750 was 0.31. Now, we apply Bayes' theorem, and we'll see how to do this. We have an and in the top, greater than or equal to 750, and took a prep course. And in the bottom, we have to add both of the and probabilities for our prep course. Either they got a passing score or they didn't. Once we do that, we will calculate the probability that we got a passing score given that we took a prep course, and it's 0.39. That's quite a bit higher than this 0.25. So we got new information, we applied Bayes, and got a revised probability. Now let's go to the next sheet and see how to do this. Here's our prior probabilities. We define the event CPA score greater than or equal to 750. This event you estimated subjectively as 0.25. Hey, then the second event, CPA score less than 750, well, we can calculate that using the complement rule. Now, these two events have to be mutually exclusive and collectively exhaustive for Bayes' theorem to be used. And clearly, you can see they're mutually exclusive. There's no overlap. You either passed or you didn't. And collectively exhaustive just means there's enough categories to count everything. Now, we're going to define the event took a prep course as PC, and the event not took a prep course as NPC. Now, this is the new information. Conditional probability of 0.6 that they took a prep course given that they got a passing score, and 0.314 took a prep course given that they didn't have a passing score. And here's our table method for calculating posterior probabilities. We start with the prior probabilities, 0.25, 0.75. So 0.25 is the probability that we've estimated that we will pass. Here's the new information. Probability the person took a prep course given that they had a passing score is 0.6. So prior times conditional, that will give us our and or joint probability. So the probability that we had a passing score and we took a prep course, we multiply 0.25 times 0.6 and we get 0.15. Now the trick is we have to do it a second time for the other mutually exclusive event, right? It was not get a passing score. So here's our conditional probability. Took a prep course given that we didn't have a passing score, 0.31. We multiply these two to get our and. Didn't pass and took a prep course. There it is, 0.2325. Now the trick here is both pass and didn't pass. Those are mutually exclusive. So all of the PCs are going to turn out to be the sum of these. So if I scroll down here, there's the sum. So that's actually the probability that they took a prep course. Well, if that's the whole, we could take each one of the individual parts and compare it to the whole. So here we're going to get our posterior probability. This is what we're after. Hey, what's the probability that we can pass given that we took a prep course? I'm just going to compare this part to the total. But remember, this total down here is adding up both of these. So we get 0.15 divided by this total. Now this is kind of, PDF didn't capture this. It's actually 0.39. So with new information, we see that probability that we pass the CPA, given that we take a prep course, is 0.39, better than our original of 0.25. Now I want you to notice what we did here. This addition of this whole column is the probability of preparation course. That means a single event. This is actually a marginal probability. So when we add this up, marginal. When we calculated this posterior probability, it's really a conditional probability. So our definition from earlier in the class, if we're trying to calculate conditional and or joint divided by marginal. Now I want to scroll down to the next page and look at this explicitly. Here's our two ands. When we add them up, we get our marginal probability of preparation course. Boom. So this should make sense. The and divided by the marginal. Now in an earlier video, we explicitly talked about this when we were doing joint probability tables. And divided by marginal gives us conditional. Here's what we did. Here's the and here is the marginal. Now the rule and the formula in the textbook, and if you're just given these probabilities without the table format, you may not immediately notice that this is a marginal probability. Here's how we listed it, and here's how they'll list it in the textbook. Now let's go to the next page and look at the formula proper. This is Bayes' theorem for a two-event case. If A1 is the prior event 1, and A2 is the prior event 2, and B is some event, the probability of prior event 1, given that B has happened, oh yeah, probability of event A and B divided by, oh look, A1, that's a prior 1. This is a prior 2, the two ands. But notice we're adding up both of the and probabilities for event 1 and 2. That, of course, equals the marginal probability. Here, it's the same thing, same exact denominator. Here's how they'll list it in the book. This comes straight from our definition of conditional probability and our multiplying rule. Instead of listing it as and, we do it prior probability or marginal probability times the conditional probability. And these two adding up give us our marginal probability. One other example before we jump over to Excel. We could draw out the entire tree diagram or probability tree. Here's pass. We decided that it was 0.25. The complement is right there. But notice, once we get to here, these are the priors. We get our conditionals. We can multiply straight across prior or marginal times our conditional and get our ands for each one of the pathways or the possible sample points. There's actually 4 sample points here. But notice, when we did our table format, we only took the PC given that pass of 0.6 and the PC given that didn't pass of 0.31. Those are the only two ones we used. These two we didn't see in our table. But if we do the whole table, we get all of our ands. And the ones we pick, the two ands, are the two PCs. So we take those, put them in the denominator, and then take the one particular and put it in the numerator. And we can get our posterior probability. That is probability we pass given that we took a preparation course. Now we want to jump over to Excel. Now here's our CPA example. We're going to have the event pass, which is 0.25. Didn't pass, that'll be our complement rule, equals 1 minus. We're going to have two other events. We either took a prep course or we didn't. Here's the new information. This is the probability we took a prep class given that we passed 0.6. We weren't given not take a prep class given that we passed, but we can easily calculate this with the complement rule since those two events are mutually exclusive, 0.4. Down here, the new information we got was took a prep course but didn't pass. That was 0.31. So the probability of not taking a prep class given that we did not pass the CPA is the complement rule, 0.69. Now with that data there, we can calculate a tree diagram or probability tree and then do our table format. Hey, I'm just going to list the two prior probabilities. So equals, and then we got this 0.25. Enter, and this one will be our probability of not passing. So that's the prior. Then we have 4 conditionals. Took a prep course given that we passed the CPA. Enter, enter. did not take a prep course given that we passed, enter, enter. Took a prep course given that we did not pass, and did not take a prep course given that we did not pass. All right, so we have our conditionals and our priors. We can simply multiply straight across. So the first conditional passed and took a prep course is going to be pass times the conditional, enter, enter. Passed and we didn't take a prep course, our prior times our conditional, enter, enter. Didn't pass and took a prep course. Hey, we're going to take didn't pass, prior probability times our conditional. And finally, didn't pass and didn't take a prep course. And enter. Now if we scroll over, we can calculate our posterior probabilities. Now here we're not given the total, but we need to notice right there, PC, right there, PC. So when we add these two together, that gives us the marginal probability for took a prep class. So equals, this is the particular and, passed and took a prep class, divided by, and I'm simply going to use plus in parentheses, the first PC and the second PC. Both of those PCs there, close parentheses, and boom, there's our posterior probability. That's the probability that we can pass given that we took a prep course. So now we have our revised probability. We could also do the same here. This is not pass. Given that we took that prep course, hey, we're going to take this one. This is the not pass and took a prep course and divide it by the same sum of the same two values. Close parentheses and enter. That's doing a tree diagram or probability tree. Now let's do it with our table. I've already filled this in. These are just all cell references pointing up there. And there's our prior. There's our conditional. That's only the PCs, notice. So we simply, to calculate our joint, equals prior times our conditional, enter, equals the prior times our conditional, and enter. Both of these are for PCs. We know that these will add up to a marginal probability of took a prep class because our pass, not pass, are mutually exclusive. Alt equals and enter. Now we can simply do and divided by marginal to calculate posterior or our conditional probabilities. Hey, the and divided by the marginal, enter, equals and divided by the marginal, and enter. So 0.39 for pass, given that we take a prep course, and 0.61 given that we won't pass, given that we took a prep course. Now I want to go over and look at one other example for Bayes' theorem. I'm going to click on B2. Here we have actually some source police data, and we have the events. You either left the garage door open in a particular neighborhood, or you didn't leave it open, and then stuff was stolen or stuff was not stolen. So our prior probabilities here, 0.2, that's the probability that someone left a garage door open in this particular neighborhood. Probability that they didn't leave it open was 0.8. Then the probability that stuff was stolen, given that they left the garage door open, is 0.5. And then stuff stolen, given that they didn't leave the garage door open. Both conditional probabilities. Now we can calculate our and. So this is the and or joint. Garage open and stuff was stolen. Prior or marginal times our conditional probability, and enter, equals prior times our conditional probability, and enter. We could have just copied that formula down. Now this is the probability of stuff stolen, alt, equals, and enter. So about 1.8% chance that stuff was stolen. Here's the probability that stuff was not stolen. Now, I'm going to calculate our posterior probability. Hey, what's the probability that the garage was left open given that stuff was stolen? Hey, and divided by our marginal, F4. Control-Enter, copy it down. F2, we have now the probability that garage was not left open given that the stuff was stolen. Now, to end this video, I want to show you down here a single cell formula. If you don't want to do this table format, notice if we have it set up like this, The priors or marginal probabilities are lined up one on top of each other in a column, and the conditionals are also lined up one on top of another. But notice what we did here. We went ahead and calculated these two particular prior and conditional. Well, this one was there too, but then we added. So notice, look at the pattern. Multiply, 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 multiply. It's like this column times this column, and then we add. If you see that pattern, you can use sum product. So the first thing we need to do is calculate this and or joint probability. So equals prior times our conditional. Now we need to divide it by the sum of both of these. Well, watch this. I'm simply going to use sum product. I'm going to take the first column. Those are the two prior probabilities, comma, and we can see array 1, array 2, conditional probabilities. The product part of sum product will multiply, 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 and then the sum part will add. You got to be kidding me. Close parentheses and enter. There it is, all in a single cell. All right, in this video, we talked about Bayes' theorem. We saw how to do a single cell formula. We saw how to do our table format. Over on BT1, we saw a tree diagram, our probability tree, and our table format for calculating posterior probabilities. And then over in our PDFs, we talked about Bayes' theorem in detail, including the logic of the formula. All right, next video, we will start Chapter 5, Discrete Probability Distributions. All right, we'll see you next video.